In this video, we're going to discuss machining a brake drum off-car using an off-car brake lathe. This is an old AMCO brake lathe. It can actually machine both drums and rotors, but since most manufacturers are going to recommend that you machine rotors on the vehicle, you'll want to use an on-car lathe for most of your rotor machining. But for machining a drum, this is the only option that you have. Be sure to participate in an instructor-led demonstration. The purpose of this video is just to give you an overview of the operation and the highlights. So let's start here with the spindle or arbor. This is the cutter tool. This is the crossfeed adjustment. We can rotate clockwise or counterclockwise to position our tool and establish our depth of cut. This is the spindle hand wheel. It moves the spindle to the right or the left. And then we have a spindle speed dial right here. So unlike the on-car brake lathe, we have a variable speed here. The on-car brake lathe just has one speed that feeds the cutter bit at one speed through the work. On an off-car brake lathe, at least on this style, we can adjust an infinite adjustment here between slow and fast and work our tool at a speed that will give us the best surface finish. This is the spindle lock knob. This is used when we're machining rotors. We won't be needing to use the spindle lock knob as we machine a brake drum. Okay. So we have the toolbar here and the toolbar clamp. You'll notice that we can lift the top of it here. We could remove this lock nut, remove the bar. We also can pivot the tool bar. We have a pivot nut here, a pivot lock, I should say. It's not a nut, it's a bolt. We can tighten it, lock the pivot into position. So these are all things we're going to start off with loose, because we'll need to make adjustments once we mount the drum. We have the cross-feed engagement lever over here. Again, this is another piece that we won't use. This is for engaging the lathe when we're machining a rotor. So you'll want to leave that in a straight up and down off position. So don't touch when machining a drum. We'll only get to that when we're machining a rotor. We have a work light here, comes in handy with an on-off switch. We have the on-off switch for the machine located here, a little toggle. Okay, on the back side of the machine, we have a pulley guard. If you open it up, you'll notice there's a 3-position pulley. We have an outer, a middle, and an inner pulley. You'll want to use the inner pulley for large diameter drums, the middle pulley for probably most of the passenger car and light truck drums that you might do, and then this small pulley for very small drums. Okay, so in order to make those adjustments, those belt adjustments, we have a knob with a little red knob here. We can rotate it to the right. That removes the weight of the electric motor off of the belt, and then you can move the belt to the appropriate size pulley. This is going to adjust the speed of the spindle. When you're finished, rotate the knob back to the left. Okay, here you'll notice that we have cone adapters and drive plates. We try to keep them neatly organized on the little pegboard here. We have small to larger sizes here. And over here we have spacers. This is the spindle nut and a spring. Okay, you'll notice that one of the spacers has a rubber bushing in the middle. This is called a self-aligning spacer. And we'll use this up against the spindle nut when we mount the drum onto the spindle. We want to be careful with these cones. Even the smallest nick or scratch can cause alignment issues. So keep them clean, try not to drop them, and hang them back up when you're finished. The better shape they're in, the better cut we're going to get on the lathe. Okay, we're going to mount up this drum. We've selected the right size of cones and adapters, drive plates. So the first thing that goes on is the drive plate, spring, The cone adapter I selected centers right into the middle of the drum. So we'll slide that on next. The spring will help push the cone adapter out into the opening on the drum. Let's make sure our tool is out of the way. Then we'll slide the outer drive plate on. We have a spacer, the self-aligning spacer, and then the spindle nut. Now the spindle nut is reverse threaded, so you'll see I'm rotating it counterclockwise to pull it up. The spindle nut is not threaded all the way through. You can see there are threads that come out to this end of the nut, but they don't come out to this end of the nut. The threads are, the nut's undercut in the middle, and the threads only go about halfway through. So you can use the nut in either direction. You'll notice I have a little bit of spindle shaft showing here, so I'm going to put the nut on in a way that I can take advantage of the thread-free opening and put the nut on again counterclockwise. Then we're going to use the wrench. This wrench just stays with the machine, and snug it down. Just give it a good tug and make sure it's good and snug. One thing I like to try to remember to do is check that the tool holder is snugly locked into the bar, in case the person that used the machine before has left it loose. Now we have the bar, we have the clamp loose so the bar can pivot. We can slide the bar in and out. I'm going to move the bar in about in the center of the drum. I'm going to place the tool up against the drum so I just have a start point here. I want to make sure that the bar clears the inner drive plate. And we're going to lock the clamp using the lock nut here, and also lock the pivot lock. Now the tool is securely fastened to the crossfeed. I'm going to move the tool away from the drum slightly. Okay, we're going to turn the machine on, and we're going to rotate the crossfeed dial counterclockwise and just bring the tip of that tool till it just scratches the inside of the drum. Okay, we're going to perform a scratch test now that's going to check the accuracy of our mounting of the drum onto the spindle. So we just made that light scratch cut. The next step we want to do is move the cutter tool in just to keep from banging it up against the inside of the drum. We're going to loosen the spindle nut. Remember, that's reverse thread, so I'm going to rotate clockwise. And we're going to rotate the drum 180 degrees on the spindle, and then tighten down the lock nut again. Next, we're going to rotate the hand wheel, the spindle dial here, just maybe like a ½ inch or a quarter of an inch. Turn the machine back on, and then again, bring that tool out until it just barely scratches the drum surface. So bring it out and then slow down so you don't gouge it into the drum. You can hear the light scratch cut. We'll back it off and turn off the machine. Now we're going to look inside. Okay, so what we're looking at after doing the scratch test is we want the two lines to be parallel to each other. Remember, we rotated the drum 180 degrees, and if our setup is good, if we don't have any scratches or nicks or chips in the cones and the adapters between the spindle and the drum, then we should see those lines parallel to each other. If they were 180 degrees off from each other, then that would be our signal that we've got a runout issue. And the runout issue is not related to runout in the drum, it's related to our setup. So doing that quick scratch test can give you a better outcome and a much more quality job. You will find sometimes drums have a little bit of run out. You want to make sure that the run out's in the drum and not in your setup. All right, the next step is we're going to wrap this rubber band or belt around the outside of the drum to silence any vibration. There. Okay, so it's necessary to install this silencer band or else we'll get a lot of tool chatter, which I'll show you later. Okay, now we're going to turn on the lathe and run the cutter bit in to where it just touches the drum to establish our 0 starting point. Okay. Now there's an adjustment collar around here that we can rotate and line up the numbers and the increments so we know where our 0 is. Now rotating the spindle hand wheel, I'm going to move the drum out so that we can remove any ridge that might be present on the outer edge of the drum. I'm going to do that manually. Once that ridge is removed, we can go back to our 0 point. And then I'm going to rotate the hand wheel in, making a light continuous cut right back into the inner ridge, usually the rusty ridge where the brake lining material has not made any contact. Might undercut it just a tiny bit. All right, so let me point out a couple of things on this crossfeed. I mentioned that we have a 0 point and an adjustable collar. You can choose inches or you can choose millimeters just by simply loosening this lock screw and rotating it around. Each increment is worth 2/1000 of an inch, or if you decide to use millimeters, each increment is 0.05 or 0.05 of a millimeter. I'm going to use inches, line up my 0. Now another thing I wanted to point out was that the cutter tool, the crossfeed, has a lot of backlash in it, meaning there's a lot of clearance between the gear teeth, on the gear teeth and on the screw. You'll notice I can move it almost a half a turn and the tool cutter doesn't even move. So you'll have to get used to that. When you run it out, you'll have quite a bit of backlash to bring the cutter bit back in before it starts to move. Now I'm lined up on my 0 and we should be ready to establish our depth of cut. So I'm going to establish my depth of cut now. I'm zeroed up on the crossfeed dial. I'm going to turn on the machine. Remember, each increment is worth 2/1000 of an inch or 0.05 millimeters. I'm going to go in about 6/1000 of an inch so I get a continuous cut. And then I'm going to engage the spindle lever. All right, before we engage the spindle drive, however, we're going to want to adjust the speed of our feed. So you're going to notice some numbers on this dial that range from 2 to 20. Anywhere between 2 and 6 is a finish cut, and anything 6 or above is a rough cut. I usually go around 10 or 12 for the rough cut and then roll it down to say 4 for my finish cut. Now what that means is the speed of the spindle will rotate. For instance, I have it on 0.08 here, or the number 8. It means that it will rotate the spindle 0.08 of an inch every revolution of the spindle. So the drum will move down across the cutter bit 0.08 of an inch for each rotation of the drum. So again, a number higher than 6 for your rough cut and a number lower than 6 for your finish cut. I'm going to set it up on about 12 here. We're going to engage the feed. And you can hear we're getting a nice continuous cut. It's a fairly quick cut, but that's okay because this is our first rough cut. I want to show you what happens if you forget to put the silencer band on. You just heard the sound of a good cut, good continuous cut. If you forget to install the silencer band, it sets up a vibration and causes the tool to literally bounce up and down on the inside of the drum. Let's see if we can hear that ringing now. Hear that high-pitched ring? Sometimes that ringing gets such a high pitch we can hear it all the way down at the other end of the shop. I have a drum over here that I'll show you the different surface finishes that we can get if we don't adjust the speeds correctly. Here's an example of a drum that has 3 different cuts. Some are the correct cuts and some are the incorrect cuts. This first cut, you can see it sort of looks like a vinyl record album. We had the speed of the spindle set up in a way that the cutter was advancing, or actually the drum was advancing across the stationary cutter at a speed pretty fast that you can clearly see the peaks and valleys here as the cutter tool dug in to remove the metal. Okay, that's fine for a rough cut. You would never want to install a drum that has a surface finish like this back onto the car. This next surface that you see here is an example of tool chatter. This is what happens when you leave the silencer band off or you don't have it installed in a way to dampen the tool chatter out. So what you see here is kind of a rough surface. It almost looks like a knurled pattern that is actually the result of the tool bouncing up and down due to the vibration on the surface of the drum. So it's gouging metal out as it bounces up and down. It's also very hard on the tool. You'll ruin a tool cutter bit really fast if you let that happen for too long. And then the surface next to this is a finish cut. You can see it's nice and smooth. It's going to wear nicely. It's going to be quiet. And that's what we want for our finish cut. That's a very slow speed on the dial to give a nice finish cut, nice and smooth. Now, as the cutter clears the drum, you can see that we've adjusted an auto stop here that will shut off the feed lever. The motor continues to rotate, but the feed stops. And again, this is a time saver, so you can be doing other things on the car while the lathe is doing its job. Okay, we just completed our rough cut, so we'll do one more cut to put a finished surface on. I'm going to turn the machine back on. Bring the drum up on the spindle to position our tool back towards the inside. And we have a pretty clean rough cut, so we're just going to take a light second cut here. I'm just going to advance it 2/1000 of an inch, and then slow down the speed under 6, so we get a nice finish cut. I'm going to select 4, and then engage our lever again. And then the cutter bit's just about to the end here. All right, so we've completed the finish cut. I'm going to turn off the machine, disengage, remove the drum. And you can see we have a really nice surface finish all the way around. Okay, so we have the finish cut on the inside of our drum. You might want to take some 150 grit sandpaper and work it around the inside of the drum to smooth out the peaks and valleys for a better surface finish. And then wash with warm water and light detergent and dry and reinstall on the vehicle. Before we reinstall the drum, of course, though, you'll want to double check with your brake drum mic and make sure that you're still well within the oversized limits before you reinstall the drum. Okay, this is a hubless drum, and you notice that we used a cone adapter that fit the center just right to get the drum centered on the spindle. If you have an older car with drum brakes in the front that use a hub, then you're going to use a different shaped cone adapter that's actually designed to get right down into the bearing race. So for example, here's the outer race on a hub. We're going to select the cone that seats right in securely to that outer race. And that'll be used on the outside. And then we'll mount the inside of the hub with a larger cone that fits the race on the inside. When mounting a drum with the hub, and you're supporting with the adapters by the bearing races, no drive plate is necessary.